Look at your temperatures to see if there is a phase change, also known as a change in state. Yes, water changes from the gas phase to the liquid phase. Be sure you have the boiling point and melting points of water memorized, which is 100 degrees Celsius and 0 degrees Celsius. Remember, there's only one type of change that can occur at a time. Either temperature is changing or phase is changing, but not both. There are two types of changes, a change in temperature and a change in phase. Only one change can occur at a time. If the temperature is changing, then the phase is not changing. If the phase is changing, then the temperature is not changing. There's a different formula depending on the type of change. Know your formula values. Q is heat absorbed. M is mass in grams. C is heat capacity. Delta T is change in temperature. You will need to know your temperature values to find your delta T. Make a list of benchmark temperatures. Start with the initial temperature and be sure to mark each phase change temperature. In this case, the only phase change is condensation, going from gas to liquid. Condensation is the exact opposite of vaporization, going from liquid to gas. Condensation will use the same temperature benchmark as vaporization. Label which equation you will use. There is one temperature change that has, so that means you're going to use an equation that has delta T in it. The other equation is for phase change. Draw a chart. The temperature starts at 100 degrees Celsius and reduces to 25 degrees Celsius, so the line will either be decreasing or horizontal. The phase change cannot begin until the steam has cooled down to 100 degrees, so the first section will be cooling from 110 to 100 degrees Celsius. Once the steam has reached 100 degrees Celsius, the boiling point and the condensation point, it will continue to release heat in the form of condensing. There's no temperature change, horizontal line. Once all of the steam has turned to liquid, it is still at 100 degrees Celsius, but now the temperature will reduce as the heat is released. As you move to the right of this graph, heat is being released the entire time. Even when the temperature is not changing, heat is being released to allow condensation to occur. Each line in the graph gets its own calculation. There are a total of 3 line breaks, so there will be 3 separate calculations. Start with the first section. If the line is slanted, that means the temperature is changing. The y-axis is defined as temperature, so the lower you go, the lower the y temperature. Q equals MCAT, MC delta T. Your starting temp is 110 degrees and your final temp is 100 degrees. Mass is 10 grams. Make sure you pick the specific heat that has units in joules, grams, and Celsius. Plug in your values according to the equation, mass times specific heat times change in temperature. To find your second Q value, your heat absorbed, notice that the line is horizontal. This means there is no change in temperature. Therefore, the phase is changing and we'll use the equation Q equals mH. H, enthalpy, is the heat absorbed during a phase change. In this case, the phase change is condensation, gas to liquid. You will likely be given the heat of vaporization and not the heat of condensation. The numerical values are the same, but the signs are opposite. If the heat of vaporization is 2,260 joules per gram, then the heat of condensation is a negative 2,260 joules per gram. Remember, H, enthalpy, is heat absorbed. So when you have a negative H value, that means heat is being released. Steam has to release its heat in order to become water. Plug in your values according to the equation and cancel out your units. The only remaining unit is joule, which is an indicator that our calculations are correct since the heat value Q is measured in joules. Repeat the process for the third section. Recognize that the temperature decreases from 100 degrees Celsius to 25 degrees Celsius. This will tell you which equation to use, one that has delta T in it. Plug in your values according to the equation. Recognize that specific heat for liquid water is not the same as specific heat of water vapor. Now that you have your heat values for all 3 sections, add them together. Take a step back to look at the big picture. The line is either decreasing or horizontal. Decreasing lines mean the temperature is decreasing. Horizontal lines mean the phase is changing. In order for 110 degrees of steam to convert to water and decrease to 25 degrees Celsius, it has to release 25,935 joules of heat. A negative Q value means heat is released.